We're investing $1,400 at an annual interest rate of 2.6% compounded continuously. We want to know how much we'll have in the account after 4 years. This is the magic phrase right here, compounded continuously, tells us that we need to use the PERT formula. The amount at the end of the term will equal the principal times e to the RT, where R is the interest rate in decimal form and T is the time in years. So our amount will equal the principal, which is $1,400, times e to the r. Well, 2.6% is 0.026 times the number of years is 4 years. That's a calculator problem. Just pick up a calculator, put this in, and you'll get pretty close to $1,553.44. Step 2 is logarithmic functions. The first one just says write this in logarithmic form. So I know this has some kind of logarithmic form, so I'm going to write the log. I'm going to write the equal sign, and then I'm just going to start filling in spots. The base is 3. The base is still 3. Logs always equal powers. The power is 9, so the 9 goes over here. That's what the log is equal to. There's one more place to put the 19,683, so we'll just put the 19,683 in here. So log base 3 of 19,683 is equal to 9. There's our logarithmic form. That's it. 3 is just asking us to evaluate log base 6 of 36. What this is saying is 6 to the what is equal to 36. Well, what would I have to put here to get a 36? 2. So this just equals 2, and I'm done. This says 6 to the what is 36. Well, that has to be 2. 6 squared is 36. That's all we need. Number 4, we're solving 9 to the 8x equals 23, round to the nearest 10,000th. So 9 to the 8x equals 23. I need to get that x out of the power. The only way I need to know how to do that is with logs. I can choose whichever log I want to use. I'm going to use one that's on my calculator, either natural or common. Most of you guys would probably just choose log. So I've got log 9 to the 8x is equal to log 23. Remember, the cool thing about equations is I can do the same thing, whatever I want, to both sides, and it's still equal. There's a nice law of logs that allows this power now to come out as a multiplier. So we're going to let that happen. 8x comes out in front of the log 9, and that equals log 23. I'm going to divide both sides by the log 9, so 8x is equal to log 23 divided by log of 9. All I got to do now is divide both sides by the 8. So I'm going to write that as x equals, dividing the 8 away, log of 23 divided by log of 9. That's equals some number. And then I'm going to divide that answer by the 8. That's exactly what I'm putting in my calculator. I'm going to do log 23 divided by log 9, take that answer and divide it by 8, and round it off to the nearest 10,000th. I should get something that rounds to 0.1784 when I do that. Pause here for questions. Number 5, I've got log of 6x plus 12 equals 1. When I don't see a base in a log, that's a base 10. So we got to remember that's a base 10. So we're going to write this as an exponential. So this says 6x plus 12 equals 10 to the 1. If I change it from log form to exponential form, I've got a simple equation. 6x plus 12 equals 10 to the 1. I'm going to subtract the 12 from both sides and divide by 6. And we're done. If we want, we can plug that in and check. 6 times negative a third is negative 2. Negative 2 plus 12 is 10. 10 to the what is 1? Log of 3x plus log of 4 equals 3. The first thing I'm going to do is I'm going to combine log of 3x and log of 4. Log of 3x plus log of 4 is log of 12x. Why? Yep. When you're adding like-base logs, you can multiply them together and to make one log. If there's no base shown, what's the base on a log? 10. So this is base 10. Therefore, I could write this as 12x equals 10 to the third. So x equals 1,000. That's 10 to the third divided by 12, which turns out to be, let's see, to the nearest hundredth. That turns out to be 83.33 to the nearest hundredth. We'll pause there for questions. This time we have a natural log of 4x plus 3 equals 1. When we see natural log, it's base e. So 4x plus 3 equals base e to the 1. We're going to round this one to the nearest thousandth. So I'm going to solve for x. I'm going to subtract 3 and divide by 4. So x equals e minus 3 divided by 4, rounded to the nearest thousandth. That's approximately negative 0.070. And we're done. 13, rational functions. Number 8, state the restrictions on the variable. This is just what x cannot be. What can x not be for number 8? Can't have a negative 3 because that would make a 0 in the denominator. Can't have a negative 4. That would make a 0 in the denominator. Division by 0 is undefined. Since that's not supposed to happen, we got to prevent it from happening by saying x can't be those numbers. That's all there is to number 8. Number 9, multiply or divide and state the restrictions. Well, it says to divide, so let's go ahead and set that up. I'd have n minus 1 over n minus 6. When you divide by a fraction, you're supposed to flip it over and multiply. So let's change it to multiply and flip it over. That means the n minus 3 is going to the bottom. And this is going to the top, but let's factor it on the way. So I've got to come up with two numbers whose product is 12 and whose difference is 4. That's got to be 6 and 2, doesn't it? So a minus 6 and a plus 2 are going to work here. This will reduce right here. So my final answer is an n minus 1 on the top with an n plus 2. And in the denominator, I have an n minus 3. N cannot be 6 or 3. Because if it's 6 or 3, then this is not going to make sense. So we go ahead and throw those two out. There's our final answer with restrictions. We'll pause here for questions. Add or subtract. In order to add or subtract, I need to look at factors. This one factors to d plus 2, d minus 2. That's going to be my LCD is d plus 2 times d minus 2. So I'm going to end up multiplying the top and bottom of this first fraction by a d plus 2. So that I have a d plus 2, d minus 2 on both of them. So what I get here, my common denominator is d plus 2, d minus 2. There's first fraction, the 1 gets multiplied by d plus 2, so I'm going to have that up there. Plus, nothing happens to the 4. It was good to go. So I just have plus 4. Simplify it if possible. I can simplify 2 plus 4. So this will equal d plus 6 over d plus 2, d minus 2. And we're done. They didn't ask for restrictions this time, so we don't need to write them. Number 11, simplify the complex fraction. All a complex fraction is at least one fraction inside my big fraction. This has 1, 2, 3, 4 fractions inside my big fraction. That's pretty complex. It's got issues. Let's deal with them. The first thing I didn't see when I first did the problem, and then after I got halfway through it, I thought, oh, that would have been easier. Do you guys see, can I reduce 4 over z? No. Can I reduce 1 over 5z? No. Can I reduce 4 over 4z? Yeah. And it would make sense to do that. Can I reduce 4 over z? No. So let's just do a quick rewrite here, because we can make things slightly simpler here. This is 4 over, I'm going to change this to x because it's easier to draw fast. This would just be 1 over x, right? You just reduce. Minus 4 over x. Actually, that's a plus. Don't change the sign. All right. So now, I look at all these little denominators inside my complex fraction. I've got x, 5x, x, and x. I need to figure out what the LCD, if I was trying to add all those up as fractions, what would be my LCD? 5x. So I need to make sure that every one of these has a 5x instead of just an x or something different. So I'm going to make sure I do that. In order to force this to have a 5x, what do I have to do the top and the bottom? Multiply by 5. So that makes this fraction 20 over 5x. This fraction already has a 5x on the denominator, so we're good to go. This one I need to multiply by 5. That gives me 5 over 5x. And this one I need to multiply by 5. That gives me 20 over 5x. Now let's go ahead and... Actually, I'm going to hit the brakes right here, because that's not the way to do it. No. Not so much. No, you're okay. Stay there. You got this. You got this. You got this. I don't want to add these things. Adding is difficult, right? Adding fractions is difficult. But multiplying by 5x, that's easy. I'm going to multiply the top by 5x. I'm going to multiply the bottom by 5x. The whole top, the whole bottom. This is much easier. Let's do it this way. So if I multiply the whole top by 5x, we're distributing here, right? 5x times 4 over x. The x is reduced. Agreed? That'll give me 20. Minus 1 over 5x times 5x. That's 1. Bottom. 5x times 1 over x. The x is reduced. I get 5. Plus 5x times 4 over x. The x is reduced. I get 20. This is 19 over 25, and we're done. We'll pause here for questions.